Right now I'm going to go through the entire lesson of finding zeros of a polynomial. So this one will be a little bit more of a lengthy video, but hopefully help assist those students who might either miss the day or might struggle on this one. This is a very complex topic, and students sometimes struggle quite a bit on this one, so I wanted to make a video of the entire lesson. And this is, to be honest, the easy version of this. We're going to get into some more challenging ones, but you've got to understand this base before we go on. So hopefully this video will help a little bit. All right, so finding zeros of a polynomial. Well, a couple things we need to determine. If the degree, remember the degree is the largest exponent in any polynomial. If the degree is odd, in other words, if it's a 3 or a 7, anything like that, it can look like this. It basically starts in one corner and goes up in the other corner. This is if the leading coefficient is positive. If the leading coefficient is negative, it goes like this. Starts in one, goes down through the other one, okay? But basically, what starts in one quadrant and ends up totally in the opposite direction going down, okay? Now, if the degree is negative, in other words, if the exponent, excuse me, is not odd, but if the exponent, if the degree is even, then it bounces up. We're used to these. These are our quadratics. They bounce up. They make a U shape. Sometimes they'll make a W shape, and these look very, very weird. But as we get into polynomials, they can add these extra little bumps all along the way here. These are our positive ones. Remember, if we remember back to quadratics, either the smiley people, so the smiley face ones, they go, they look like a smiley face. They both go up. If it's negative, if the leading coefficient is negative, then it goes down, and it can have a lot of different bumps all along here, depending on what type of polynomial it is. But those are important pieces to understand about what the graph is going to look like. All right, so we want to solve this one by factoring, and you're used to doing these. You've done factoring in the past before. So I want you to go ahead and do that right now. So go ahead and push pause on this video. I want you to solve this one by factoring. Remember, we're going to use the Berry method is what most students like to use. That's the one we go 10x in the first one and 10x in the second one. Then we go 8 times c, all that kind of stuff. Okay, so go ahead and push pause now whenever you've finished it. Then come on back and push play. Check your answer here. Hopefully you ended up that the answer x equaled 1/2 and x also equaled -1/5. Now, we're used to doing those. That's nothing really new to you yet at this point. But what I want to bring to your attention is what this graph looks like. If we were to graph this one, the graph looks just like this. It crosses the x-axis right here at -1/5 and at +1/2. Now, that becomes important because what we're going to be doing in this section is finding the zeros. Where did we get the term zeros? Well, this is where the y value is 0, right on the x-axis. Y equals 0. So the x-intercept here is going to be 1/2, 0. And on this one it would be -1/5, 0. Well, this is where the zeros come from, okay? The y value is 0. So if I'm asking you on this one, instead of saying solve by factoring, I could say find the zeros. And if I asked you to find the zeros, it would be the exact same process here. These would be your zeros, 1/2 and -1/5. So really, it's something that you already have seen before. We're going to give it to you some of the ways that you've seen before, as well as add to it to make it a little bit more interesting for you, a little bit more of a learning experience. All right, so here's what we have. If I ask you to find all the zeros on this one, and that's all the places in which it crosses the x-axis. So we're looking at this one, and doesn't look like we can factor that one. That's not going to be easy. Well, let's back up just a little bit. The very first thing we have to do is we're trying to find the zeros. So in other words, this is where the y value, or this h of x, equals 0. So the very first thing I'm going to do is convert that one to a 0. So everything else here remained the same. I just changed that one to a 0 because that's what I'm trying to find are the zeros. Now I can go through and try to solve it for x. The very first thing I'm going to do here is factor out the greatest common factor. So is there something that all three of these components here have in common that we can take out of there? They do. They all share an x. So I can factor out an x. If I factored out an x out of each one of those, then I'm left with 5x squared minus 11x plus 2. Okay, the x went away here. Instead of 2x's, instead of x squared, I'm left with just x. Instead of x cubed, I'm left with x squared. Perfect, no problem. Now, what we're going to do is factor what's left inside here. So that's when we're going to go a times c. 5 times 2 is 10. It has to multiply together to give me 10, but add together to give me negative 11. Hopefully you found out that that was negative 10 and negative 1. Now this is our Berry method. We've got our 5's here in both. We know this is wrong. 5x times 5x does not equal 5x squared. But now what we can do is see if there's a factor we can pull out here. A 5x and a negative 10 has a 5 that can be factored out of that one. So I factor out my 5, and whatever I factor out, I cross off. So now I'm left with x times x minus 2 times 5x minus 1. Now this here, x minus 2 times 5x minus 1, should give me this original one here if I were to either use the box method or FOIL those two back together. It should give me this original one. That's when you'll know that you factored it correctly. Okay, but in this case we did, so we're okay for right now. So I'm left with x times x minus 2 times 5x minus 1. Now what I'm going to do here is set each one of these parts equal to 0. I know that x equals 0, that's one answer. Now you're going to have 3 answers on this one, hence the cubed here. That's going to be a clue there. 3 answers on this one, so x equals 0, x minus 2 equals 0, and 5x minus 1 equals 0. Now what I'm going to do is solve each one of these individually. You'll find out here that x equals 1 and x equals 1/5. Solving all 3 equations at 1, I'm sorry, x equals 2, I'm sorry. Add 2 to both sides, x equals 2. So there are my 3 answers here. I've got x equals 0, 2, and 1/5. Those are all of my zeros here. So when we're asking to find all the zeros, that's all you're going to need to do here. It's quite a bit. You're going to need some extra practice on it, but I think that you can. And if you were to take and graph these ones using your calculator, you plug this equation right here into y1. You plug those in, and you find out that it crosses the x-axis right here at 0, 2, and 1/5. You might have to zoom in a little bit in order to see it, but that is where it crosses the x-axis. All right, now let's bring, there you go. There's what it looks like. Let's bring in one for you guys to work on. So go ahead, I want you to try these. Remember, we're going to factor out the greatest common factor first. If you're not sure how to do that, back it up the video just a little bit and you can see how I did the last one. Hopefully that will help you on this one. But go ahead and push pause now. When you're ready, come on back and push play. Check your answers here. Again, we had 3 answers on both of these. And we cannot be afraid of fractions. Fractions are okay on these. You'll often have some fractions on these, and that's just fine. All right, now I want you to go ahead and factor these. Find all the zeros, and part of the process is going to be factoring them. Number 2 here is a little bit more challenging. Let's see if you can pull this one off. So go ahead and do these. Push pause, and when you're ready, come on back and push play. Check your answers here. Number 2 was a challenge. There's no question number 2 is a challenge because this one had a b squared that we could factor out of it. And b squared equals 0. Take the square root of both sides. B equals 0. Now this one sounds a little bit weird because the degree on this one is 4, meaning we should have 4 answers. 2, 8, and 0 is only 3 answers. Technically speaking, we have 2 zeros. This is the b squared equals this. There are 2 zeros here, and if you graph that one, you'll start to see it. We'll get to more of graphing that one and more complex problems. I'm not as concerned with that, but technically there are 2 zeros here. We have a 2, 8, and 2 zeros. 0 multiplicity of 2 is technically how you would say it, but that's not important at this point. All right, now I'm going to give you this one, and I'm asking you to find all the zeros. So we're going to go through the same process. We're going to try to factor, to write it equal to 0. Factor out a greatest common factor. On this one, it looks like there's no x's. We can't factor out an x. But we can factor out a 5, so I can take a 5 out of all of these. Now then, what we're going to have to do is factor what's left. Okay, now, we haven't factored these before. We've got an x to the 4th minus 5x squared plus 4. And we really don't know how to do those, but we've done some similar ones in the past. Now, I'm going to bring this one in, this red one, just for illustration purposes. This is not the problem, but if I gave you this one, you'd know how to do it. 2 numbers that multiply together to give you 4, but add together to give you -5. Well, that would be -4 and -1. Well, that's going to be the same case here, only now instead of x minus 4 and x minus 1, it's going to be x squared minus 4 and x squared minus 1. Okay, now x squared times x squared gives me x to the 4, so this works. And then if we were to do our box method and do all of these out, we could do it. That would work. So this is going to be the only catch. We're going to factor them just like normal. The only difference is going to be this one. Instead of just x minus 4, it's going to be x squared minus 4. All right, well now what we can do is set each one of these equal to 0. Okay, let's back up just a little here. 5 equals 0. Well, that one doesn't really help us. That one isn't going to be a part of it. Here, you can technically go x squared minus 4 equals 0. Move your 4 to the other side. Take the square root of both sides. That will work. You can also do the same thing here, or you can factor these. These can still be factored, so I factored them. Many students like to just go from right here and go add 4 to both sides, then take the square root of both sides, and you end up with a plus or minus 2. Same thing with this one. That works fine. In this case, I factored them. X plus 2, x minus 2 is my x squared minus 4. Remember, two numbers that multiply together to give you negative 4, but add together to give you 0. There is no b in this case. So that would be positive 2 and negative 2. And same thing for the 1 here. Positive 1 and negative 1. I set each one of those equal to 0. I color-coded them here so that way you knew where each one of these equations came from. And you just simply solve them. You're going to solve all of them. So we've got a positive and a negative 2 and a positive and a negative 1. So x equals plus or minus 2 and plus or minus 1. There are 4 answers here. And that's what our degree on this particular one told us. It would be up to 4 answers. So, but again, most students like to just go from here and just move the 4 over to the other side. That's fine as long as you understand that there is a plus or minus 2 here. It's not just 2. 2 is not your answer, okay? All right, let's get some more practice on this. I've got 2 different ones here. I want you to go ahead and try both of these. And remember, you're going to factor them the normal way, but instead of it being an x, it'll be an x squared this time. Okay, so go ahead and push pause now and push play whenever you're ready. Check your answer on the first one. And if you want to, just pause it here. That way you can take a look and then go on and try the second one. But you should have plus or minus 1 and plus or minus 3. The second one was a little bit more challenging, so I wanted to kind of go through this one with you. We get to this point here, and again, some students like to just go ahead and move the 9 over to the other side, and you find out that your answer is plus or minus 3, which is fine. But look here, we've got an x squared plus 4. That is not x plus 2 times x minus 2. That doesn't work. That's x squared minus 4. So this one in this case does not work. So what you're going to have to do is set that one equal to 0, then actually solve it. We're going to move the 4 on the other side by subtracting. So x squared equals negative 4. Now I'm going to take the square root of both sides. I take the square root of both sides, my squared goes away, and I've got the square root of negative 4. The square root of negative 4 is not 2. Remember, these are our complex numbers. This is an imaginary number, to be specific. And this imaginary number here is plus or minus 2i. Okay, so you'll need to write that in. We do have imaginary numbers coming in here. Now this one we've already done. Those are pretty easy here. X equals plus or minus 3 there. So our answer in this case is plus or minus 2i and plus or minus 3. Okay, so this one's a little bit more complicated, but not overly so. The big thing is if you can move it on to the other side, realize any negative inside of a square root sign is an imaginary number. That's the hardest part there. All right, we're going to do the last one here, so go ahead and try these two. Now this number 1 here is a challenge. So it's not going to be x, and it's not going to be x squared when you factor those. So see if you can figure out what it is. Go ahead and push pause now. If you're unsure, you really have no idea, then go ahead and try number 2 first, then come back to number 1 after I show you the worked out solution. But go ahead and push pause now, and when you're ready to check your answer, you can push play again. Check your answers here. All right, so we had quite a bit on both of these. Now this one ended up being an answer of just negative 1, which was really weird. You know, the square root of, the cube root of negative 1 is just negative 1. But I thought that we had 6 answers here. Well, indeed you do. It is negative 1 6 different times. Rather than write negative 1, comma, negative 1, comma, negative 1, comma, negative 1. 6 different times, we just write negative 1. Otherwise, it's just redundant. So we're okay there. And I want to draw your attention to this portion right here. This is plus or minus I square root of 5. Okay, so plus or minus I square root of 5, that is going to be an important piece here. So that's how you'll have to write this. Remember, the imaginary number comes out in front of the radical. All right, well, that concludes this lesson. I hope that it helped. If you do have any questions, you can let me know. You can go back in and watch the video as many times as you'd like. And hopefully start to kind of get the grasp of it a little bit. This is a very, very challenging lesson, so it will require some practice, and you'll probably have to go back through and watch several videos on it.